Alright, we're live on YouTube now. I'm gonna open OBS and go live on Twitch as well. Just gonna check my drivers first. Yes, it's correct. Alright, we're live on both places. Then I'm gonna start my music. You guys can barely hear this, right? You guys can barely hear this. Alright, how's this? How's this? Alright, how's this? How's this? Okay, I think that's good. I'm just gonna. Okay, I think that's good. I'm gonna turn it down for myself. I'm gonna turn it down for myself. So I'm just gonna quickly do a post. So I'm just gonna quickly do a post. Alright, so here's what we're doing today. Yesterday we got the shader working, and I'm really satisfied by how it came out. It looks so good. It looks so good. It looks way better than that. This was the kind of look I was actually imagining. Uh, like it's not a proper face. Like it's not a human face. It should look eerie and should look, terrifying. And like from this angle, it looks like that. This looks like a zombie face. Like this actually looks like somebody who's dead and pale and just uh, what is it called? Like there's a lot of darkness here. There's paleness, but that's not what I want. I wanted to look. I wanted the faces to look like they're cold, eerie, um, and just they should not look organic. Should look like porcelain, and this does give that kind of a look. Um, so I'm going to continue working on the heads today. Today we are working on the mechanics. But before moving on there, I'm going to actually uh, let's write down what we're doing today. So enemy mechanics we are doing later on. But first we're gonna close the shader program. I'm gonna close the shader, work. And in order to do that, here's what we have to do. I just want to see the different settings that we are given. Actually, and just gonna bring it in center. Yeah, I just want to open up the shader file, and I want to see. Just want to play with some of these values, like the multiplication by 2 and other values. I think there's something we can do there which can improve the look even better. Maybe later on we come back and also change the gradient here. But for now, uh, let's actually do that right now. The gradient part. I'm gonna quickly open the gradient here. Oops, that's not the gradient. And we're using this one. I'm sure the gradient is gone from yesterday. Is it? Yeah, it's gone. Alright, I'm gonna just use this. I'm gonna play, just try to get it working similar to the color palette we have. Wow, what? Did you see that? Alright, it really help if I can see what's going on behind. How do I bring this? Oh, there you go. Alright, if I hide this. Yeah, so we brought down the lightness, I guess. Okay. Let's just actually reset all the values. And work from the scratch. Oops. Just gonna make it more darker. I want the hue to be a little cold. Somewhere there, and there should be less saturation because we already have color in the light. It's killing the gradient. Let's see how this looks. Maybe we don't want it to be this much white, or maybe we don't want that multiplication by 2 that we were doing. Also, do we really have to do this? Okay, let's see. I'm gonna copy this, paste it here, and then I'm gonna also. So this is the original one. I'm gonna comment this out. I'm gonna remove the saturate function, and let's actually see if it makes a big difference or not. I don't think so. It made any difference. Alright, I'm gonna take a screenshot. Um, and let's actually undo our change. Oops. Oh, it undoes all, like, goes back to the first change. Why does it open the same shit? Alright, now to go inside the pictures folder, open it from the screenshots. Alright, which one is the first one? I guess the last one is the latest one. Yeah, there's no change whatsoever. I can't make any difference between these. So, okay, first of all, let's go back. Let's move the camera like this, because that's where the things would change mostly. Save this file, go back here. There's no change, so I'm gonna keep it there. This and also this, right? Let's, instead of 2, let's just stick to 1. It's gonna make it a little more, it's gonna make it less brighter for sure. So it's gonna be a little more darker, and it does not look bad actually. Does not look bad. How does it look in comparison to the inputs? So now it has the same color as this. Yeah, it actually still looks better. You still don't lose a lot of shading. You can still make out the details over here. It's more smoother for sure. This is a little hard. That is more smooth. Uh, but if I do it by 2, then it makes it look a little more bright. It makes it look brighter, and I can maybe make sense why it does that. Also, what is this? Oh, we are not doing that. Right. So now radiance is basically the light color. Wait, so where are we applying? Okay, we are applying it here. Alright, so maybe we can try applying this here. gonna keep it like that. I'm gonna go down and I'm gonna multiply it here. Warp to diffuse. Wait, where's my head? Wait, I didn't remove it. Okay. Yeah, it's just gonna make it more. So we're just going to a smaller value, smaller and a smaller value, because this gives you a decimal and then you're multiplying it again with a decimal. So basically, that's basically a division operation. Yeah, now all I have to do is make a call whether I want it by two or not. These Valve people did it by two because they wanted uh, to give artists a little bit of control over the follow. Do I really care about it too much? Do I really care about it that much? We can either do this or we can do that. Actually, I'm leaning towards this because then all you have to do is make a new texture and it will give you the same. Like you can try to, control it by the gradient. Um, Also, let's actually export this and put it there and see. Oops. I'm gonna import it directly to Unity. Alright, let's apply that and see what's let's see. This looks so cartoonish. Is that the one we took from the? If that is the one we took, then it actually looks good. Between this and this, I think I like this. Between this and that, this definitely looks like it's of this world, and the color palette matches. But I like the fall off in this better. So maybe we try to match the color palette of that texture and of that gradient, and then we're sorted. This just has a better fallout. Okay, that is a little weird, but I mean it's okay actually. Yeah, actually this I'm gonna stick with this. I'm gonna come down here and we are applying that. I'm just gonna keep it white. Yeah, that we're done to make it part of the world. Actually, it was actually really good. Yeah, it's good. Yeah, that does make it look like it's porcelain, like it's some ceramic material. I don't know why I don't get the shine here. Because maybe this is in the map excluded from. Now it's gonna look absolutely weird. Alright, this is cool. Now what you have to do is you have to make it animate, as in not literally animate. You have to make it do stuff to the player, to scare a player off or something like that. And now it's a weird part because I may have to start my webcam and um, record myself for the facial expressions because we're going to use some animations here. Um, for the face for different states. Maybe we can do that later. We can do that as the last part, and I can do it maybe on off camera. Right. So right now I have this frown, which you see when I hit play. That's what it does, and that's like an ideal animation, idle and animation, and then it'll have different states like follow player and other stuff. When it's aggroed onto the player, and then attack state, and then die and stuff like that. Uh, how do you do this? First of all, let me just clean this project up a little bit. Is that the hero? Yes, that's the hero. Can I apply all the changes? There are no changes. Great. Can I delete all this and use this head from now on? I can. I can delete these two now. Then, first of all, I'm gonna delete this, so we don't need it now. But I'm not gonna delete this. I'm gonna delete this one. Yes. And then I'm gonna go in the scene where we were testing the heads. And yeah, it's gonna say that. But that's okay because we are doing that again. Enabling the spheres, deleting all this. This is the floor. Whoops. Floor. That's the wall. Um, the other spheres. We don't need it right now. Oops. I have to read all this. Bring this head to 0. And bring our player also. If you're looking away, yes. I'm gonna hit play. Alright, what do we do now? What are we doing? What are we doing? What are we doing? What are we doing? Yeah, what we are doing is we're making the mechanics. Right. First, let me just check the chat. Okay. Actually, yeah, I can close the shader work now. Um, I think we'll come back to it later if you find, when we add more faces. For now, we can just close it. I don't know how to strike through here, but this is done. We're doing this. Enemy mechanics. Um, Alright, what are the mechanics? First of all, let's see the structure. The animator is here, and there is a sphere for some reason. Yeah, this is for the collision. Actually, you don't need it now. Is it? Because the I had it for the hair to collide with something, but we don't need that in this new system. What apply all this? Um, yeah, we have to make it follow us. Alright, I don't want to have a trigger here. Instead of that, we're gonna have a behavior script. That's gonna have logic for how far or close the player is. Um, so what you're gonna do is floating head, or how about balloon controller? I'm not gonna call it balloon. I'm gonna call it head controller. Head control seems like it's a player related stuff. Yeah, I'm just gonna call it floating head controller. FH. Let's call it FH controller. Um, Wait, what is this script? Why is it going in builds? Scripts. And then we're gonna have some logic about for this, right? So, what are the states? There's ideal state, and then there is the. So in ideal state, we want the head to roam around. So there will be that behavior, and then there is the aggro state, and then there is the attack state. Oops. And then there is the dead state. So in this, we wanted to chase the player. I've not yet figured out what we are doing in attack. Does it do like a dash towards? Does it strike the player and come back, or does it just keep, Or we can do a one hit KO, right? So the head would chase the player, and then we'll not have this health bar. So there's no health bar. If the head comes to the player and ties the rope around, like if it comes close enough to the player, then it's gonna try to get the noose around the neck of the player, and then if that happens, then the player dies basically. But if you shoot or try to run away, then it's back in the idle state. um, so attack is basically almost like a chase, or trying to uh, get the player by the noose. How do I write it? I'm just gonna write news logic. Um, do we use a state machine or not? Mm, keep it simple and not have a state machine. It's not that complicated. You can definitely have an ENA. Like not a, yeah, like that. Attack, and then what was the last one? Dead. Um, Current state ideal, and I'm not gonna do all of that. I'm gonna remove this code. Actually, let's write the. And yeah, there'll be a state transition. There'll be a function for state transition. But right now, I'm just gonna write. I'm not gonna do all of this now. Actually, yeah. Let's actually do all of this. Um, so when you're in idle state, you wanna call roam function. Oops, not random. Roam. How do you spell roam? Um, and in roam, what we do is um, yeah, code for roaming behavior. So in roam, what we do is, how do you want this to work? So we definitely want them to be in a particular area, because if they are just flying everywhere, then it's we don't really want that, because player is basically traveling from A to B, right? The player is going from A to B. There's just a single path. Um, and yeah, I mean there are little there's a slight derouting, but it's not like the player eventually ends up at B, no matter what. So we don't want them to go just anywhere. We want them to be contained in areas, um, like particular areas. So how do you define this area, and how do you tell it to only roam in that area? Um, yeah, we want a random destination. Uh, I hope there's a function in Unity for that. So if I do I do vector, or do I do transform? Let's actually see if there's one in transform. Get location or something. Yeah, I don't think so. It's transform. It can't be transform, or maybe a vector. Uh, Also, I've been wanting to see this move towards. Okay, I'll take a look at that later. Or maybe I do math f dot. Um, Alright, let me just do float x equals to math f dot gamma to linear space. I want a point in a space. Okay, but how do you define a space first? I mean, it can be a collider. Maybe that's how we define a space. So you have a collider. I'm gonna first declare the collider on top. Um, Actually, let's use that method as a scratch. Right? You have a collider. See that. How do I get a location? Get. So I want a position inside this collider. Is there or even if there's a way to find whether a vector belongs inside this collider or not, that'll be great. Closest point, and then there's closest point on bounds. There are so many gets here. Has modifiable contacts. Okay, I want to see what that those are. Closest point on bounds. Unity collider closest point on bounds. Also, let's see. You know, let's see it according to each collider that we have. So I'm gonna have a box collider. Yeah, whatever. BC dot. If I do vector 3, v equals to, or you get the size. Well, we don't want the size. We want the location inside the collider. All these are visual scripting related functions which I don't really care about. These are the only real ones here on top. Get geometry. Geometry holder. Center bounds. What is bounds? What is the type of bound? Type of object returns. It returns the bounds. Okay, interesting. Encapsulate. Intersects. Set min max. Square distance. String max and min. Closest point. Contains. Okay, let's see what contains this. Contains. What does contain? Wait, I want to see it properly. Why does it shows and it comes and it goes away? Read only. Okay. Is point contained in bounding box? Okay. Is there a way to get a point inside the bounding box? Transform position. Okay. Well, let's actually see what this is about. Why is there to open? Public closest point on bounds. closest point on the bounding box of the attached collider. I don't think so. This is what we need. Uh, okay, let's actually see bounds. Does it show my chat here? Doesn't show the chat here. Earlier it used to, but then I closed that window and I don't know how to open it. Okay. Bounds represents an axis aligned bounding box. An axis aligned bounding box, or AABB for short. Okay. Is a box aligned with coordinate axis um, and fully enclosing some object. Okay. Because the box is never rotated with respect to the axis, it can be defined by just its center and extents, or alternatively come min and max points. Okay. The center of the bounding box. Using these two, we can actually generate a random point. What are the types of this? Yeah. Grows the bounds to include the point. Wow. Expands the size of it. So vector 3, which is great. So we have two vectors, min and max. And how do we use this to generate a random position? Mostly, or actually, forget it, not mostly. It's gonna show me some else. Look at this. Alright, so yeah, I'm gonna first define a collider here. Serialize. Why does it not show me already? I'll have to fix this because it's actually annoying. So we are taking a box collider, and I'm actually very used to doing this. So we're taking the box collider and we're getting the bounds, right? Oops. So we're getting the bounds. Actually, I'm gonna do this in the start. I'm gonna comment this out. Let's actually do it in the start. What do we do? Get the bounds, right? And then we get the min and max. Vector 3 max and then we get the min, um, and then we want a random position inside. But I want to actually see how these look like. Yup, perfect. Where's my product here? There you go. Take a look at the chat quickly. Um, 1 second, guys. I'm getting a text which I need to attend. Alright, let's get back. Yeah, so let's first assign a bounding box. I mean a collider. Right, so what we do basically is just create all these cubes. Um, just use a collider on the cube. So if I scale this, it doesn't scale the thing, and I'm gonna actually scale it. So maybe you don't actually do this using the transforms. Maybe you directly modify the collider, because if you do it like that, um, actually let's have two of these. One is here, and then one I'm gonna put here. Um, Alright, so one is at x0, this 6, and that is 0. The other one, I'm gonna reduplicate it. Oops. It's gonna be at x minus 6. Um, do I just make it go in the positive? Yeah, let's actually do that. I'm gonna hide these two for now. We're gonna bring this all the way here. Let's see the first cube. Or let's bring it to x0. The second cube, I'm gonna move 6 units there. And I'm gonna actually put that script here. Let's see what it returns. This is what you get. First one is the min, right? Alright, which one? But which? How do I know which object is this? Um, Whoops. How do I redo it? Shift Y. Oh my god. Okay. Debug dot log. First, put the name of the object. So this would be game object dot name Robin. Yes. Really, I'm gonna quickly take a look at the chat. Hmm. All right. So for the cube one, okay, let's start from here. So for this cube, is that the position? I'm gonna copy and paste it here. Cube and cube one. We're gonna take a look at this and we're gonna come out of the play mode and take a look. I'm gonna create a new game object here, and I'm gonna decrease. I'm gonna actually reset the transform first. Remove this because we don't need it. Bring it up at 6. Make it smaller but readable, and copy paste these values. I hope Unity takes these values. What? Alright, let's just manually put it then. So it's gonna go away. Okay, actually I'll take it from here. So for that one, it's 0.5, 5.5, and this one is minus 0.5. So yeah, it's basically there, and the other one is 0.5, 6.5, 0.5. So it's giving us this. It's giving us positions in world space, which is great. But I want to see. So it gives us, because this is the front, it gives us this. Then that's the one that you get. So basically, x cannot be smaller than that, right? X cannot be smaller than that. It has to be greater but lesser than this. Y can't be smaller than that. It has to be greater and lesser than this. And Z can't be smaller. Z can't be greater. Oh, actually, Z can't be greater. I mean, smaller than that. So for min, everything has to be greater than these values, or equal to these values. And for max, all of this has to be lesser than these values. So it is what it says. What it says it is, right? So using that, what we can do is we can get three vectors, random dot range, and same for that. Random dot range. Gonna take this, put it here. Whoops. And I'm gonna. So now we basically have a position, but let's actually. I don't want to do this. Let's use this random or next destination. Get random points within bounds. That's actually a great idea. I can create that function. Vector 3, get random position. It's crazy. So if you are returning that, then I would like to just not declare these and just write this instead. Whoops. And then return that instead of doing this. How do I say to use, go ahead and use it? Also, this U came here for some reason. Oh god. Oh, it's glitched out. Great. Why is there a U everywhere? Oh, because is it because I did that? Well, why is there a U everywhere? There's a U here, there's a U here. Okay, never mind. So you have your next destination, and then I'm gonna print it only if it's inside the point, right? So if contains next destination, then you print it. Great. Really quickly taking a look at the chat. Is this even live? Because it's stuck in the beginning of the stream. At the beginning of the stream. Yeah, it's actually live. Alright, let's see what did we get. We're looking at this, right? So we got this point, and then we can try and see if that point is actually we can try and see where that point lies. It lies there, which is actually inside it, right? So that is great. So now what we have to do basically is we'll just create these zones. Like, oh yeah, this is the other thing I wanted to see. What if I just scale these like this? Now let's do that again. 2.33. 3.67 uh, and minus 2.33. And the other one is 2.33, 8.33, and 2.33. So yeah, it is actually correct. Um, yeah, I can just manipulate the transform and it will work. I can just change the transform and it should work. But what? Okay. Oh shit. Okay. Oh, I didn't. Uh, I just I didn't change to that sphere. Now I'm gonna change to that sphere. 2.2 that, 4.56 and minus 2.12. It's right here, which is inside the thing, right? Yes, it's inside. Does this work no matter what I do? Like if even if I do, oops, even if I scale unevenly, will this work? Why is it always? Oh, because I've done this, right? So if I scale it unevenly, will it still work? Let's see. Um, these bounds. Minus 786. Oops, 0.86. 2.75. Wow, what is this sound? This is before AI. Can you guys see, man? This is before AI. It's crazy. Was this in Death Stranding? Nine point 2.5 and then 4.58 and then this is so it works, right? It works. What you gotta do now is we gotta decide, do we want it to just randomly go in, because the bunch of heads which are in this area would all just you know kind of move in different directions and they may go through each other and all of that. So we want that, or do we don't? Instead of that, we want them to kind of circle here, like slowly circle in this area. I feel like that will be more easier to do than this, um, or maybe it's more intuitive for sure. So we take a sphere, and I don't know if it's bounds or what for a sphere, but you definitely get a radius and a center. And what happens if I scale it? I mean, why is radius not scaling? Okay, if I scale it like that, okay, let me make a script. Test sphere test. So what this script does is it gets the sphere collider, right? Oops. Let's save this over here. And what it does is a couple of things here. We want radius. We want to print the radius. So float radius and then float center. Yeah, it will be a vector 3, right? Center, center, and then radius and center. So that was a unit circle. I mean unit sphere. Now I'm gonna take another sphere, scale it by 5, and see what's the scene with this. Okay, so it is actually taking it from the collider. I'm gonna try this. I'm gonna duplicate this one. Um, I'm gonna move it inside here, reset it, and then I'm gonna only change the collider. I'm gonna try to make it contain the bigger square. So it's kind of that. So it's half. Yeah, it makes sense. It's a half of the scale of its own scale. So what we have to do, so what this um, is it times or is it, no, it's not times, it's basically half of this. So radius is not dot radius, but it's um, transform dot scale local scale by 2, or yeah, local scale dot x by 2. So we have to assume uniform scaling here. So what happens with we have a center, we have a radius, right? So now we can make some trigonometric function, write some trigonometric function, and generate position values for the squares to kind of float in a circular motion over an area. Quickly look at the chat. I have 3 views on YouTube. That's great. That's better than yesterday. Yeah, let's see what do we get. Yeah, this is what we wanted. Um, all right, so we are closer to the solution now. So we got the center, we got the radius. Now, how do we get the next position? I know for a fact that it's a trigonometric function. Like I'm confident that's a trigonometric function, but I don't know how to write it. Uh, so maybe I can maybe do it on paper first. Do I have a drawing app here, like whiteboard or something? I don't have whiteboard. Maybe I can draw it inside photo field. I'll take a big one, big canvas. Alright, so what you have to do is you have to first make a square. Where are the shapes? Oh, there are the shapes. Well, I mean, not a square. First make a circle and not have this, but have this, and little bit more border. We want something like that. Move it in the center. How do I move it in the center? Do I? Yeah, I have to hold space. Shift. Got it. Okay, now it's in the center. I'm gonna take a new layer. I'm gonna go take a brush. Where is a brush? That's the brush, and this is perfect. So the center is somewhere here, right? Roughly somewhere here, and we have to find a position. And actually, so that's the center, and that's the radius. Why is it not drawing here? And that's the radius, and this is 2.5 for us. What we have to do is, so center is 0, comma 0, or it's actually the transform dot position. It can be anything. Let's say it's 1, comma 1. All right, so this point is this. Where is the eraser? What? The eraser actually works like a paintbrush? Oh, that's the eraser. Okay, quickly. Let's do this quickly. Yeah, so that's the center. And I can find this in the x-axis easily by adding 2.5. Right, so if I add 2.5 to this, you get 3.5, which is this point here in x-axis. So this would be 3.5 comma 1 comma 1. Very easy to find. And then the next point. Yeah, so that's the easier part. Finding the first point is easy. You can either subtract to go get this point, or you can add to get this point. But we want the next point after that. So once the heads, they'll be placed somewhere. Let's say they're placed here. Once you get this point, they'll start moving towards this point. Once they reach this point, you want to find the next point, which is their next destination, and that point has to be inside the circle. And all you have is these values. So you have the center and you have the radius. You can find it using some trigonometric function, I'm sure. This already makes it does not make with this point. This is, let's see how it makes. Oops. Why does it always do that? Why does it go here? Okay, do I have to click and do this? Yes. So you know this is 2.5. That that has to be a right angle. Alright, that's the right angle. You want to find this point. That will be some value. So you have to find this basically. Because you have this already. So this point is basically uh, I mean it's the Z actually. This point is basically this and this. So you have to find this. That's a right angle. That's the adjacent. Maybe we use this. So it's opposite upon hypotenuse. What is it called? Hypotenuse. Hypotenuse. Was it called hypotenuse? Hypotenuse. How do you say it? Hypotenuse. Oops. Hypotenuse. You say it news.
Hypotenuse.
Hypotenuse. Hypotenuse. So you have the hypotenuse, which is 2.5, opposite upon hypotenuse. Oh, it says opposite upon hypotenuse. This gives you the, what does it give you? It gives you something, right? It is soka, so, kya, was it like this? Okay. It's actually 10. So, was listening to me or what? Opposite upon, I just know. It's actually sine, I think. Yeah, it's actually sine. What does this give though? It gives you the angle. We don't need the angle. Right? Sine theta equals to opposite upon gives you the angle. Alright, let's ask here. It gives, oh god, it gives us the angle, correct? Can do both again. If you know at least two sides of the triangle, you can find the angle using the inverse function, often called, okay, we don't want that. We don't we don't have to find the angle, we have to find this. But we don't know one of these things, so we have to use the, but we don't even know the angle. I mean, we can define the angle. This angle can be defined. You can say it's 5 or 10. I'm gonna go with 15 or 20 or something, right? So if this is a right angle, and if that's 45 one, then this is half of 45 or somewhere in that range. So it's 20 or something, right? So I'm gonna go with 20 degrees. So it's gonna move like this. It's not gonna move. It's gonna move like this, and then it's gonna move like this. It's gonna make a polygon instead of. This is fine. All right, so we will give it the angle, but we want to find the other side. If you know an angle and the hypotenuse, you want to find the opposite side. So we have to use arc sine. Not arc sign. Do we have to use arc sign? We have to use this, whatever that is. Finding a side. Is it called? Is it called inverse? Let's see it in Unity. Float side equals mathf dot sign. Alright, show me the tooltip. Calculate the side length of the inscribed cube. So we have arc sign. How do I get the inverse sign? There was a function for all of this somewhere. I've used it before. Is it inside float? There was arc sign, there was everything. Or do I have to import that new math library that Unity has come up with? How do I get inverse of where are the inverse trig functions? A cos. Oh, it's A sign, is it? Okay. Value to compute the arc sign for f in the range that returns the arc sign of f, which is the angle in radians. The sign is f. Calculate the side length of the cube that fit inside the set. Yeah. So we send the angle to it. Right, we send the angle and then we multiply it by the hypotenuse and you get the side. So this angle in radians is 20. There is a thing that you have to do, right, to convert mathf rad dig to rav. Oh, okay. Oh, so you multiplied by the degrees. Okay. 20, and then you multiply this by the hypotenuse. Hypotenuse is the radius, and you get the side. Now this side is the z. So now we'll have to form the vector using. Okay, what about y? I can just have a range that I'll serialize. Point on square. Point on square, center plus. No, I don't want all of this. I don't want to do all of this. New, so this is the new next destination. It's gonna be that's gonna be the side. I mean, okay, wait a second. Let's go back to photo field. So we got this, and then we have the radius. So radius will be in x-axis. Y-axis, I'm gonna put some value here. Let's say 3, and that's the side. And I'm gonna serialize this. Actually, I could have put instead of 3, I could have put 5, but it's okay. It'll be inside the sphere then. Actually, it would be a little off because 5 is the diameter. It'll be a little away from this sphere. Okay, let's see what's come here. We've got this. Mm, not sure if this is correct. Also, why is radius? Okay, this is for the smaller cube. This is for the one that we're using. Z is like weird. Yeah. Do we have to do it? Do you have to multiply it by the position? Like, do we have to normalize according to this? I want to move this out. Actually, I can do it on this. Be even better. 0.1. And I'm gonna remove this, and I'm gonna move it to this 2.5, and that is 3, so it will be outside, and it will be, and this is that. Where is that? Yeah. Wow, it's so off. It is so off. The X is so off. Why is it so off? Can't be that off. Uh, let's see. Let me reset it. Wait, what? Okay. Hmm. Why is this 0.5? It should be somewhere. It should be 2.5, isn't it? Alright, actually, if I move it out and do it, let's see. Yeah, it won't be actually even closer to it. It will be again far. Um, because I've not normalized it, right? So this is not even the viewport. Oh, is it inside something? It's inside something. Oh, it's underneath this. Okay. First, let's actually find the position um, of this sphere. Simply by doing the simpler maths, which is just this. So yeah, you get it in the center, and then you move it in X by 1 2.5, right? And then whatever this value was, I can add it here. 0.89. And I can add the next thing for this. Hmm. It's actually a smaller value. Alright, wait a second. Plus 2.5. Okay, yeah, it's there. Now for this sphere, I want to find the next value, which is here. How do you decide what to add to X so that it comes back here? I figured out the Z, right? So Z has to be this 0.89. And now if we see both of these, they will have similar values. Not the same, similar. Because we just handpicked that. But I can bring this to match. Bring that other one to match this. Yeah. Um, and then wait, let me actually bring it to the border here. All right, it's one minus 1.67. Yeah. So how do we find what to subtract actually? It's actually an add operation, but because you have a minus um, things, that's why it becomes subtraction. We have to find the x now. We got the z correctly. How do you find the x? So if I'm gonna try one more thing. I'm gonna duplicate this, and I'm gonna add 0.89 here. Yeah, it just makes it go outside. 0.89 just goes 2 inside. But x is actually correct. Hmm. So, yeah, we found this. Now we have to find this. No, we have to find this. We found this. We have to find this. So that is actually adjacent upon hypotenuse. Adjacent upon hypotenuse. Adjacent upon hypotenuse. So, was it? What is it? Yeah, it's cosine. Um. So, one second. Yeah. So this is basically transform dot position dot z plus this, and that will be transform dot position dot x plus not the radius, other side. This will be cosine. Uh, yeah, let's hit play again. Let's see what do we get this time. Alright, so the next position that we got is this. Let's actually move it to that position. Minus 1.61, and this is 17 point. Actually, wait a second. Wait a second. Yeah, all the positions are same. Now this we have to add. Oh no, it's actually this is already the. This is after all the equation. After all the, not the equation. After all the the addition. Okay, that is still outside the circle. That is still outside the circle. It's close to it, but it's still outside. Hmm. Oh, it's actually arc cos. That should fix this. I'm gonna quickly look at the chat. Uh, how do I see how many are watching this? There's one viewer, that is me there. Okay, there are zero right now. Alright, let's stop and play. Hit play again. Alright, let's see what will we get now. We get that. 1.58. Wait, what? It's so far off. Am I sure if it's arc cos? Yeah, it's actually not. It's not. It's none of these are. It's not inverse. It's a uh, normal trigonometric sine and cos. So how do we use the inverses actually? That's in radians. I think it's for converting find the angles using inverse. Okay, never mind. I'm gonna bother with that later. Uh, yeah, this is the one. Minus 1.61. 1.61. That's not actually. Oh yeah, that's very close to the circle. Now let's move it in the Z. Moment of truth. It's actually outside the circle. So I'm giving it this angle. Sine is what? Sine is opposite upon hypotenuse. This is the opposite angle. We are finding this. That is this. Correct. And that is adjacent upon hypotenuse. This ka, which is also correct. So is the radius wrong? But radius is not wrong because it's not wrong. It's just simply not wrong. Maybe this is uh, something that we need not do. Degrees to does this take does it take radians in radians or in degrees? Unity matter dot sign. Okay, it's in radians. Am I using it wrong? 2 pi r. This is the r. Oh, this is not 2 pi r. This is 2 pi upon this. One second, guys. Wait a second. Can't be the other way around. Is this will it? Yeah, it won't come on this. Okay, I think it does. One second. Let me just. It appears to be on the circle if I add 3. But we want it to be on the circle even here at the origin level. I mean, it somewhat is. Is it? Am I watching it wrong? Yeah, it's on the circle. If I put it in wireframe, you can see it. It's on the circle. Yeah, it's on the circle. I'm so happy this worked. Now what we do is we just keep implementing this by 10 or something, by 10 or 20, and you keep getting the next position, and that's how you find the stuff. And for the height, for each head we're gonna use a different. We're gonna have a range, and then we're gonna do a random from that range, and we're gonna do it in steps. So whatever the height of the head is, we're gonna increment by those steps, the the new height or the other ones, and then we can also write a code in such a way that the formation is such that they don't collide with each other. the heads don't collide with each other. Um, but when they're following the player, they may collide with each other. But you can maybe write something that so that they can try to avoid each colliding into each other. Because that'll look ugly, and I don't want it to look ugly. Right. So I mean, Valve has done that with the deadlock thing. Grave skull. They all kind of float in a way and they don't collide with each other. Deadlock, grave.
Has he turned off the lighting? It just looks very dull on his screen. You see these cars, right? They actually don't have colliders and they don't collide with each other. I've never seen them colliding with each other. You're gonna die. No, no, die. Because it's spoiled. Wait, did he use his skull? Because it's went on cooldown. Yeah, he used his skull on the farm here.
See, they don't collide with each other. They never collide with each other.
Only when they're attacking, maybe they collide, intersect. But I'm sure they've timed it in such a way that uh, they all attack at different time, different intervals, so they end up not colliding with each other. Yeah, it's disabled the skybox. I don't think. I mean, maybe he's done something with the lighting also. He's so dead. He's so dead. Wait, how did you die there? Yeah, I'm getting distracted and engaged. I got distracted watching the gameplay. Wow, I got that kill also. Yeah, those ghosts do a lot.
Alright, let's start coding this then. Um, I'm gonna delete all of this. I'm gonna keep one of the bigger ones. I'm gonna delete. Oh, wait a second. Yeah. This, this. I'm gonna use this. And do we need this? We don't need this. We're gonna put this code inside the controller. So this controller is gonna have its area assigned. It's gonna be a sphere collider. I mean, we don't really need it to be a sphere collider, honestly. As long as it has a radius, and we actually doesn't have to be a sphere collider. But I'm gonna use sphere collider because just for the sake of visualizing the area. And I'm gonna delete all of this. And I'm gonna get random point within bounds. We're gonna change the name to something else. Get random. Get not random. Get the next. Get next point in sphere. What this is gonna take is it's gonna take the current one. It's gonna take the current angle, right? So you give it the current angle, and it gives you the next one. So we're gonna have a starting angle, the current angle, and we're gonna put increments of the angle, step angle, right? It's a step for the angle. It's gonna be 20. Then let's go down. Then it doesn't actually require because we have cast it on top, but we can make it so that it requires. But do we need to do that? I don't think so. And we need the height, right? A range of height. We can actually change the data structure and make a unique data structure for the areas, but I'm not gonna do that. This is gonna be a serialize. Oh god, just give me that on top. Just give me the serialized field on top, guys. Serialized field private. Oops. A private vector 2, uh, height, range, and then we're gonna take one and then flow with that. So we're gonna have this head is going to have its own my height, my floating height, my floating height, and I'm gonna just do that here. M underscore my floating height equals to height range. Yeah, and then we're gonna come here and we're gonna um, start writing the code by doing all the math magic.
who did on the other code. 1 second. I want to see if this works. You don't really need a center, honestly.
Yeah, this is the code actually. We don't really need the center. Current angle, radius, current angle, next destination, and then we increment this. It becomes greater than or equal to 36 with reset to 0. This is solid, guys. Um, yeah, so I think we'll need a move also, because move is a common operation between all states um, for the head. Alright, I'm gonna check the chat quickly. So this you want to call when the head is in roaming state and reaches the next position. I mean reaches the current reach the current destination. Um, and you can have a threshold for that for the distance that it has to reach, and then you can change the destination. Um, we can put all of that code inside Rome, but I want to make it cleaner. Let's see. Alright, so when you enter this, what you want to do is not gonna have any destination, and we are gonna assume that you're reaching Rome. You're coming inside Rome for the first time when the game begins. So the first thing we wanna do is we wanna get it. And we're gonna assume that the head is spawned somewhere else. So we wanna teleport the head to the first location, and then we're gonna start moving it to the next, right? So um, maybe we have another state called none, and the default is none. And we have a function called I would like to write it somewhere down, but it's okay. Change state, and we're gonna send the next state, and it's gonna be idle. I'm gonna write that change state here, but what it does first is we're gonna put a if ladder here, or a switch ladder. Hmm. Yeah, we could use that interface based that state machine, but I'm okay with this actually. So the new state is idle, which means we are transitioning to idle from some other state. The first thing you want to do is reset the angles, right? So what was it called? Current angle. Current angle equals to 0, and you want to find the next destination. Get point in sphere. You wanna call that here. Vector 3. And then you want to teleport your head to this position. Um, and then you want to transition to that. Um, and we are calling that here. I'm going to remove this. I'm going to put it here. Delete this. Oops. Delete this. Um, and then Rome gets called here anyways. And then we're gonna come inside Rome, and then we're gonna move. We're gonna get the position first and then move. Yeah, we're gonna do this basically. Oh god, we're gonna have so many states. I don't wanna deal with all this. Maybe we just have a boolean for is moving or not. Bool is moving equals to false. And yeah, when you enter this, you You set it to false. But when roam gets called, you set it when roam. So what you do here is, can you not do that, please? M underscore moving. So if you're not moving, wait, what was it called? It was this. So if you're not moving, then oh my gosh, cancel. So if you're not moving, uh, then you wanna do this. What we're doing, bottom. Copy all of this. Um, indent it well. And we want to set moving to true. Okay, maybe you set the moving to true here. Um, so you get the next point and you set moving to true. Then if else, if you're moving, this is in the next frame. Um, you know, I'm gonna have to cache this. Then I'm gonna have to cache the destination. Oops. Private vector 3 m underscore destination. Oops. Alright, so I'm gonna set the destination here. Uh, can it just stop suggesting you? How do you make it stop suggesting you stuff? Destination. You don't really need this. And then now you have a destination. So you move towards that destination. Okay, there's a. Yeah, this time I'm gonna see what this move towards really does. Yeah, so you actually set it to false and correct. Yeah, this is sorted actually. It's gonna keep making it rotate. I'm gonna have a speed for roaming, right? I'm gonna have serializable, please. Movements, roam, speed. Uh, yes, please. Now that is really helpful. Right, I'm gonna come down all the way here, go all the way there. Speed into that. All right, let's see. Let's see. Yeah, so you can actually already start putting it here. Remove this script. Actually, I can keep it, doesn't matter. I'll quickly check the chat. Yeah, we got it working. You can see it's tracing the sphere. Alright, I can hide the mesh. Um, and in case you wanna see that, you can see that. Oh yeah, it's kind of going in circle in that area. This is great. Now we have to make it so that um, one second. We can actually make it even more creepy by changing this. Every time you get a new destination, you can change this. But firstly, what I'm going to do is I want to make it rotate and look at the destination. It's going towards. What does move to? What's the difference between move towards and LURP? Is it just does it carry out the addition in its like on its own, or moves vector incrementally towards the target point? Okay. All right, we're gonna make it look at the destination. So how do I make it so that it does not snap? Uh, you can make it do that also. But let me just see what it returns anything or not. It does not. But there are a couple of overrides. I'm interested in knowing what these overrides are. Okay, none of these are very interesting. Transform dot rotation.
What does this do?
Okay, got it. That would that do? Oh, yeah, that would kind of do. Of course. I'm gonna go inside. I'm just gonna. Oh god, oh god. Actually, I don't want to click alpha and don't receive shadows. Oh god. Okay. And also, don't do all of this crap. But if I can render the back face, that would be great. Check the chat quickly. If I do both, it looks ugly, but it's helpful. If you want to see a volume, then it's helpful. Alright, so this is our new spawn area. It's gonna spawn something here. I'm in the roam area and let's see how it goes. I'm gonna increase the roam speed to 20 maybe. It's weird. And I'm gonna in the this I'm gonna hide this actually. Alright, this is great. Now I'm just gonna add a tiny addition, which is whenever you find the next point in the circle, want it to find a random point in the height. Alright, and I'm also gonna change all this. I'm gonna call this a different name. So it'll be the new Z. and this will be new x, and there will be a new y, which will be a random range.
I mean, these are big enough. This is big enough of a range to.
Make a significant change, and there is some y rotation I can see.
It doesn't actually move it. Oh, because we're not putting it. No.
This looks sick. This actually looks sick. Um, Now I can make it so that this changes not so frequently. For that, I have to write a lot of code. Like I have to cache the last interval. Like first of all, I have to expose that field, at what intervals I want to do. Secondly, I have to cache the last one. Right. So to be private. Do I call it float or integer? Height change frequency. Yeah, this I can delete. And then I have to cache this integer counter, correct? Um, and this we have to change every time we come here, or every time we come in this, right? So every time you come in this, you call that change frequency counter plus plus, and then you reset the counter if it's wait, what is this? You just reset the counter. You don't do all this. Yeah. You heard, you reset the counter. I don't want that suggestion. And then you um, in here you can have that code uh, that does this. What does it do? It does counter. We check the counter. If it's greater than or equal to this, then you want to do that. Otherwise, okay, but we don't have that cache. Now we have to cache this. Now I have to cache this. Private float. Um, this is a member function. I'm gonna call it that. I'm gonna go down, and I'm gonna use that here. Yes, that's correct. Correct. Use that, please. Please use that. How do I make it to that? Okay. I mean, we want to do this in the first run. So maybe we do decrement instead of an increment. Right, so you come here, it goes in this for the first time and it's 0, and it is 0. So when it is equal to, lesser than or equal to 0, right, so when it's lesser than or equal to 0, you get a random position and you add it here. Then it will subtract. So if it's lesser than or equal to 0, then you subtract. So it never goes beneath 0 basically. Five actually looks good. Is it gonna get a new while? When will it get a new while? Hasn't yet got a while. Should I serialize this to inspect? Alright, let's see. Yeah, now it gets a new. One. Now it should get another one. There you go. Alright, I'm gonna increase. I'm gonna do two things. I'm gonna increase this. Um, and I'm gonna decrease this. I think 3 is a better number. Whoa, whoa, whoa. Gonna go all the way down. Do you want it to do like this? Right? Yeah, so this has to be 2. You want a greater height. The other thing is I have to fix the origin for this. Wait, why is the origin showing there? Wasn't it somewhere else? If it's there, then it's great. Yeah. Wait, why was it showing somewhere else then? I'm just gonna hit play, let's see. Or I'm gonna have two different speed. One is for that, and the other one is for rotation. Serialize field aggro speed, not aggro speed. Yet this is roam rotation speed, and roam speed is fine, but maybe you can rotate even slower. Um, 5F, and then I'm gonna go down, and I'm gonna put it here. All these so far are just for roaming, by the way. So I can just have a header. Current step. Did I not? Um, current state. This. I'm gonna bring all of these together. And I'm gonna also bring these private, the non-serialized ones, at least the ones that belong to the roam state. Uh, Right, these other ones are just generic. And here I'm gonna add a header. Or idle set. Right. You wanna just call this state roam. Actually, I like it idle. Um, yeah, I hope these values are retained. Oh, it's not wrong though. Oh, now it's wrong. The header. Actually, I don't want the slurp. Slurp just makes it look weird. Just simply lurp. Just simply lurp, and I think this is fine. didn't mean to do that. I'm gonna quickly check the chat. Uh, yeah, wait, we didn't we have the Whoa, it looks cool. It already looks cool. It already looks cool. I mean, the whole area is gonna be elevated, so all these weird ass things won't happen. Maybe we can decrease it just a little.
Maybe we decrease it just a little.
And we also, I don't want to change it that much. But one thing that definitely want to do is just switch on the mesh renderer and move this above. So move it off the ground. Um, maybe I can decrease this length as well. Alright, that's it. Hide the mesh renderer over here, and it looks cool, man. It looks just all the up in the sky. This looks really good. Alright, I want to test this. If I increase the FOV, so that I don't have to look all the way up to, let's say, 80, right? And to make it look even weird. And then, okay, here, if I add a Panini projection, does it fix it? Yeah, it does fix it. As in, I can use this to fix this issue. What is this? Oh, I can actually use this to fix this. Alright, this looks cool. So we got the roaming state done. The next state that we have to work on is this aggro, and then all of this. Um, Once I get this done, I can start working on the news because I have to yet model it and rig it and make it work with the physics. Um, so yeah, that's the main task, and I'm gonna also test the look. Yeah, so actually we got done with this. I'm gonna take a break. I'm gonna come back or maybe continue working on this tomorrow. But I'm satisfied with what came out today. So I think that'll be it for now. Uh, Let me see if I can take time to come back and work on uh, the the agro part. I wanted to get done at least two of these today. So I'm gonna try coming back. But for now, this is it, guys. Thanks for joining.